Okay, today we'll be starting 9.5 day 1, which is on the sine and cosine ratios. A lot of people are tempted to say sin and cosine. Don't say that. It offends me. It's sine and cosine. So just like we did tangent ratios yesterday, sine and cosine ratios are related. They're talking about uh, in right triangles, kind of talking about the ratio of two sides, but this time we're throwing in the hypotenuse. So we see in our box here, let triangle ABC be a right triangle with acute angle A. The sine of angle A and the cosine of angle A, it's written as sin A and cosine A, but we still say sine of A and cosine of A, are defined as follows. So let's start with sine. The sine of A is equal to the length of the opposite leg divided by the length of the hypotenuse. So kind of the same as tangent, but we're throwing in now hypotenuse. You can see it's still a ratio between two sides of the triangle. So for sine of A, we have our opposite leg divided by the length of our hypotenuse. That's our sine of A. To find our cosine, we take the length of a leg adjacent to A and then the hypotenuse as well. So for both of these, the denominator of your ratio will always be your hypotenuse. And then sine is always your opposite. Cosine is always your adjacent. The kind of mnemonic device that's often used is SOHCAHTOA. So, KAHTOA, which is for sine, opposite, hypotenuse, and the other one, cosine, adjacent, hypotenuse. And then TOA is tangent, is found by taking the opposite over the adjacent. So SOHCAHTOA is kind of at least how I was taught to remember, which sides we're using. So our first example is going to be kind of similar to how we started off when we were doing the tangent ratios. We're just going to go from a basic level. We're going to find the sine of S, the cosine of S, the sine of R, and the cosine of R. So sine of S is equal to our opposite side divided by our hypotenuse. And that's equal to the opposite side of S would be 63. Our hypotenuse is 65. And then it wants it it asks for a decimal 2 rounded to 4 decimal places. So get out your handy dandy calculator. Let's see if mine turns on. All right, 63 divided by 65 is boop, 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 boop. And we're rounding it to 4 decimal places. That is approximately 0.9692. Now let's keep going from there. We'll take the cosine of S, which is then we just did now we're going to go so that's adjacent over our hypotenuse. Again, hypotenuse will always be on their denominator. Adjacent to S, that's 16 over 65. So again, we do some division to get it out as a decimal. So 0.246 2. We round to 4 decimal places. So there's a sine of S and a cosine of S. Let's switch colors and let's do the sine of R to start. So the sine of R We're still going to use the opposite over the hypotenuse. Since we're talking about angle R though, our side lengths will be different. So the side opposite of R is 16. Our hypotenuse is always 65. And you may notice that the sine of R is the same thing as the cosine of S. So we already know what that is because it's written just above. Now let's find the cosine of R. The side adjacent to R is 63. Our hypotenuse is staying as 65. And would you look at that? The cosine of R and the sine of S are the same as well. So we're going to be talking about, as the unit goes on, kind of this pattern, why the cosine of S and the sine of R are the same, then also why sine of S and cosine of R are the same. We'll talk about more as the unit goes on. Again, that's just kind of just starting at a basic level. We'll kind of dig more. We're going to spend 2 days on this, so we're just starting, just basic level understanding of sine and cosine. Sine and cosine are also complementary. We can talk about complementary angles with them. Where complementary angles add to 90 degrees, right? So the sine of an acute angle is equal to the cosine of its complement. And then the cosine of an acute angle is equal to the sine of its complement. So if we say A and B are complementary angles, meaning that they add to 90 degrees, then the following statements are true. So if we take just, let's say we have the sine of A. The sine of A is going to be equal to the cosine of 90 degrees minus A, and that's going to be equal to the cosine of B. Why we take this 90 minus A? Because it's complementary, because A plus B has to equal 90. So if we take 90 minus A, we're going to get out what B is. You can see that pattern through all of these. To find cosine of A, we use sine of 90 minus angle A. That'll give us sine of B. Then we take sine of angle B is equal to the cosine of 90 degrees minus B. That's equal to the cosine of A. And then you can see how this last one kind of mirrors the second one, but again, our cosine and sines are flipped. All those kind of sine, cosines, 90 minus A minus B may seem confusing, but it's actually pretty straightforward. So if I wanted to write the sine of 56 degrees in terms of cosine, I'm going to follow this first formula up here. So I'm going to say, well, my sine of 56 degrees, that's going to be equal to just the cosine of angle B, because they're complementary. So I'm going to do this. I'm going to say, well, cosine of 90 degrees minus angle A, which this is sine of A. So angle A, the measure of angle A, is equal to 56 degrees. So I'm going to put a 56 in there. And that's equal to the cosine of B. And this cosine of B, or the measure of angle B, we're getting from taking 90 degrees minus 56 degrees. This 90 minus 56 is that B there. So we could take the sine of 56 degrees is equal to the cosine of, and then all you have to do is take 90 minus 56, and you get out 34 degrees. So the measure of angle B is 34 degrees. So these two angles are complementary to each other. And these are also sine of the 56 is equal to the cosine of 34. So if you were to plug these two values into your calculator to get out the same decimal answer. You'll do a bunch of these on your homework just to get some extra practice, but again, you're just taking 90 minus whatever angle you're given and rewriting it in, whether it asks you to rewrite it in sine or cosine. Okay, last problem. Find the values of x and y using sine and cosine. Round your answers to the nearest tenth. Like we did with the tangent ratios, we're always going to start with the angle. And let's just start with sine first. So if we use a sine of 26 degrees, that'll be equal to our opposite side over our hypotenuse. Remember, sine of 26 is a number. We're going to treat it as a number as we solve. So the sine of 26 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 14. So then we solve for x by multiplying 14 on both sides. So 14 times the sine of 26 degrees is equal to x. So then x will be equal to, round to the 10th, 6.1. All right, now let's use the same angle, but now we're going to use cosine to find our other side. Because there's no way that we can solve for this adjacent side without using cosine. We could use tangent, but it specifically asks to use cosine. So we're going to follow what it asks. We're going to take the cosine of 26 degrees is equal to our adjacent side divided by our hypotenuse. So cosine of 26 degrees is equal to adjacent side. That's y. Our hypotenuse is 14 still, hasn't changed. And then we have to multiply each side by 14 to solve for y, or our adjacent side, as you may call it. So we take the cosine of 26 and then multiply that by 14. We would get out that y is equal to 12.6. That's rounded to the nearest tenth. And there are your two sine lengths, 6.1 and 12.6. And it's kind of matching up what our diagram is giving us. X looks like the shorter side, and we know that this second longest leg cannot be larger than 14 because our hypotenuse is always going to be our longest side. So we'll spend a second day on this. Your homework really consists of doing problems like example 3 and example 2. You'll kind of do some ones just like example 1 where you're kind of just writing it as fractions or simplified fractions. But try to remember this mnemonic device. It'll help you a lot if you can commit that to memory. Make sure if you have any questions that you're reaching out. You can get working on your homework assignment now, and best of luck.